Welcome, and thank you very much for taking the time out of your day to learn with us a little bit more about soil steaming. My name is Amanda Littleton. I'm with the Cheshire County Conservation District, and we're delighted to be one of the co-hosts here today in bringing this workshop to you. We're here with our partners from the National Center for Appropriate Technology. We have Andy Pressman. We have UNH Cooperative Extension with Jeremy Delisle. Piccadilly Farm with Bruce Worcester, University of Vermont Extension with Becky Madden, and we have Andre Cantelmo here with Heron Pond Farm, and he's also part of the Becky Farm initiative, which helps connect people with SUE soil steaming equipment. And so you're going to hear from all of them later today as we go through some of the presentations, and then we're going to be saving a great deal of time in this workshop for Q&A and opening it up to hear, to get some answers to the questions that you all have. So this event is made possible with funding provided by the U.S. Department of Agriculture through the Sustainable Agriculture Research and Education Program through their partnership grant program, as well as through the Vermont Specialty Crop Block Grant Program. Would love to start having people provide some introductions in the chat because we have such a large group here and we're going to be expecting quite a few more. We're just asking folks if they could in the chat put their name, their farm name or organizational name, as well as the town and state they're from, and what your experience level is with soil steaming. I think we probably have a pretty wide range of folks' level of experience, and we just want to try to get a feel for who's here with us today. So if you don't mind just putting that in the chat, that would be great. And so we're going to be utilizing this chat feature for questions for the panelists. So throughout the presentations by both Becky and Bruce, if you come up with questions, please take a moment to type them into the chat because we'll be monitoring that. And when it comes time for the Q&A that Jeremy Delisle is going to be hosting, we'll be referencing those questions, making sure we cover them. So please do put them in there. And just some other, ground rules, just want to share that, if you can, please do mute when you're not speaking, because it does make it more pleasurable experience for all of the other participants. And I also wanted to let everybody know that this is being recorded. We had multiple participants request that it is recorded because they couldn't attend the event or the entire event. So we'll be posting it on the Conservation District's website, as well as NCATS and UNH Cooperative Extension. So it will be available to others as well. So I think with that, that covers all of our bases to get started. So with that, I'd like to turn it over to our first speaker, Becky from UVM.
Thanks, Amanda. Thanks for having me. And it was really funny. Actually, my mom lives over in Cheshire County. And last week she sent me this, she was like, look, there's a steaming presentation. You guys should attend. And my husband wrote back to her that he has a crush on one of the presenters. So here I am. I guess she didn't really actually open it and see who was talking. So I work for UVM Extension, and I also have a farm in Orwell, Vermont, and we mostly grow in high tunnels. And like many other people, we've had a chickweed problem emerging. And I first heard Andre speak about this, I don't know, maybe 8 or 9 years ago at a Vermont vegetable and berry growers meeting. So it's been planted in my head for a while. And as the chickweed has emerged as a problem on our farm, and as I see it on other farms that I work with, a lot of people growing in high tunnels, I decided to, I guess, kill 2 birds with 1 stone and conduct a little research. So we have a specialty crop block grant to do this research, and it's not a very big grant, but we are, doing a 2-year trial, and it might turn into something bigger. But really trying to address this question that comes up a lot about the soil health impacts of steaming. Primarily, what I'm looking at is addressing chickweed problems. So I'll talk about that more, but I know Andre and others have experience with different issues, and there's a lot more depth you can get into with steaming. So as many of you know, growing greens in high tunnels is becoming a more important part of our industry. And we really rely on it, especially to bridge that gap between tomatoes and the off season. So And this is what things looked like a couple years ago in one of our tunnels. Serious chickweed. And I know a lot of you are familiar with this scene, but with only 2 of us on the farm in the winter, weeding this is pretty impossible. And also the biology of chickweed is really well suited to tunnels. It loves high nitrate. So as a lot of my other work is improving nutrient management in tunnel tomatoes, which has meant increasing nitrate and potassium levels, and chickweed loves that. So in a sense, we're creating the perfect scenario for chickweed. So it loves those nutrients. It also is a winter annual. It produces cleistogamous flowers, which you won't actually see them bloom. They'll produce seed on their own. So even when you're like, chickweed's not in bloom yet, but it's still dropping seeds like crazy. And from some of the literature I've read, what you see is only representing 6% of the weed seed bank. So once you see it looking like this, it seems like a lost cause. And I know people have tried lots of ways to combat it. This is what it looked like. I think it's really a big problem in direct seeded crops in particular, because it's coming up at the same time. And this is a couple weeks later. So that spinach is just kind of a lost crop. My husband wasn't happy that I had a control plot in our study. Not a good on-farm research objective. So hand weeding is, again, like not happening. I know Andre and a few others have looked into solarization. It's really hard to achieve those temperatures in a tunnel. If you get the right perfect window of time, I think you can do it. And there are some opportunities there, but with that quick transition, like a lot of us have between tomatoes and greens, it's really hard to do that. We do feed it to our cows. They love it. They eat a lot of chickweed. But my favorite taste tester on the farm did not approve of it. So, and we're also thinking about other problems in tunnels and what we can achieve with steaming there. So this isn't like the direct objective of my research, but I am really curious about what the impact of steaming is on diseases and pathogens. And as I've jumped more into the literature of soil steaming, it's pretty clear that it's emerging right now as a substitution for methyl bromide. So it's taking the place of intense fumigation, pasteurization, soil sterilization. And in the past, like when it first developed in the 50s and 60s, that was the point too, was to sterilize soil. So our question really is, do we need to be sterilizing soil if we're talking about these in-ground kind of organic environments, or what's the happy medium there? So this is really going to make all of you happy who have the rented steamer in the Cheshire County Conservation District, because this is what we ended up buying. And it's a lot of people start with this. I think Andre started with this type of machine. It's an old tobacco steamer. They used these in the 50s, I think. Ours came from Canada. There's a few people in Canada who are fixing them up. And it's basically, the guy who delivered it first was like, it's like a big tea kettle on wheels. And these are the different parts of it. The important thing that the guy in Canada is doing is fixing these heat exchanger tubes. He retubes it all. And apparently that is the wear part on these steamers. Everything else actually on ours showed up pretty much broken, and we were able to replace it. So I think the tubes are the thing that are a hard part for us farmers to fix. But I think ours had a rough ride down from Canada. So we ended up replacing the burner, a lot of the plumbing, and it ended up working just fine. But now, one of my big questions here is, what temperature are we going to achieve, and what are we trying to kill? So this is from one of the books that I've really liked. It's Ken Baker, and they looked at a lot of different sterilization, comparing methyl bromide, solarization, and steaming. So what temperature? All of the literature that I see points at 180 degrees, and that's what most farmers are doing, 180 degrees soil temperature for half an hour. And you can see from this chart what that wipes out, pretty much everything except those few resistant weed seeds. So you're, as far as I can tell, blitzing the soil, biology, weeds, pathogens, everything. It's the objective they were trying to achieve with this technology originally in conventional systems. Now, if we're looking at chickweed, what is the temperature that's knocking it back, and how long is it knocking it back for? And I was also curious at how low these temperatures are. Like you can get good control at around 140 for pathogenic fungi and bacteria. And then Pythium is quite low. That's a big problem for us. And then also, we're killing all the nitrifying bacteria no matter pretty much what we do. So all these things are at play in our tunnels, and it is a contained system. So just kind of thinking about how to manage for that. And the question I get from farmers all the time with any of these things, with tarping, solarization, steaming, people are really into soil health right now, and they want to know what the impact is. And it's a pretty broad question and a hard one to answer. But I also know when Amanda and I first talked about this, she was like, well, we're a conservation district. We're supposed to be promoting soil health practices. What about the steamer we just bought? So I think it's an important conversation at least to have. And a lot of people are trying to apply this in the field. California is going pretty big scale. There's a professor, Steve Fenimore, out there who's doing really cool work on weed control and plunking these big machines in the field. And in Europe, it's been in use for a long time. So big questions, big potential. So just to summarize, these are our questions. You know, what's the effect of these different steam temperatures on chickweed, microbes, and nutrients? And then kind of tracking these improvements maybe in soil disease and what the longer term picture is. What are things going to look like in a year or two? So this was our setup. Again, this kind of clunky old steamer. We did end up researching different materials. I know Sue's steamer has a lot of them. We were doing this on a really low budget. And we looked at, there's a place out of Japan that uses this kind of plastic tubing that was quite expensive, but we realized that dental sterilization tubing is the same for weights or steam delivery, you can hole punch it. So I'm trying to source different materials that were more affordable. Of course, COVID, you know, the dental supply places were like, we don't have any of that right now. So this is what it looks like. You can burn, in ours, it's oil or kerosene. We're hoping to get our hands on some biodiesel. It's a really crude setup, but there you go. So here's how we, you know, again, and I should totally, if you haven't figured this out already, I'm very new to steaming. This was our first year doing it. Andre's got 10 years of experience. And so I think what you're going to hear from me is the like mistakes we made and things we're learning, and then he can tell you how to fix all those. But this is how we did it this year, was getting our steam hose out to the bed, tarp it, and make sure those weights are really good. Also figuring out the area you want to steam at a given time. We did some pre-inflation. We first used a shop vac blower and then switched over to like an inflator blower from our greenhouse to get the plastic up off the surface. And then you fire the beast up, and I actually can't see that picture, but that's what it looks like when it's going. And just keeping an eye on everything. It's a low pressure steamer. It's not very dangerous, but just making sure that, you know, not wrecking it. And then this is our first try, was using this this bed. I think I can play this for you, but we ended up switching over to like a wider bed. Andre's probably like tearing his hair out right now, seeing what a mess our steaming. This is our first try. Got the blower going, the water hose, the kid, and there's the steamer parked out there. So no, there's no big science to it. Just kind of going for it. Our big problem was getting to 180. One of my treatments was hoping to get to 180, and we just couldn't get there. So this is tracking the temperature over time. And you can see that the dotted line is the air temperature under the tarp, and the red and blue lines are different corners of the tarp. And we just got to 160. What's also interesting is kind of how long it stays there after you stop the steamer. So it's not, you know, you can hold it for half an hour, but how long it actually takes the soil to cool down is, I think, an interesting thing to consider. As you can see, it's above 100 degrees for quite a few hours there. So our challenges were the learning curve, getting this set up. We got it late with COVID, and the timing of it before we get greens in the ground, that flip between tomatoes and greens, you have to allow yourself extra time for the steaming. And, you know, in terms of the science, running an on-farm trial always has its ups and downs. I did want to point out this calculator. I can send you guys the link to that Chris Callahan at UVM Extension helped develop. And I've found that it's quite accurate and helpful. So you can input your the capacities of your machine, how big an area you want to steam, and then it'll tell you like, well, it can tell you how big an area you can steam at your desired temperature and depth if you put in the capacities of your machine. So you can play around with this and sort of figure out, you know, how big a tarp to put down. And for us, when we changed our burner, we changed the nozzle size and we went down to a 2 gallon. We just, we got a used, like on a Craigslist, Beckett burner, and the nozzle on it is only 2 gallons per hour. We need to increase it to actually get that 180 degrees. So that was our limitation, was the nozzle size. So I'd say you want at least, Andre could chime in, but at least a 3.5, if not bigger size nozzle for the machine we have. But the good news is, even with our clunky rinky dink trying to figure things out, and the plots where we were like, oh, we didn't really get it very warm. This is our very first go of it. Got to 130 degrees. Holy cow, there's no chickweed. And this is what those 2 plots at like around 140 degrees, which is way below the recommendation. I was like, oh, we just like, our whole house is going to be chickweed. Look at that. Really good stand of spinach with no chickweed in it. So that was really encouraging for me. And also this reduction in damping off. So this is in the control plot. I pulled up 341 chickweed seedlings in 1 square foot, and also noticed like at least 25%, if not more, of the spinach damping off. So soil-borne Pythium wasn't controlled by steaming. Whereas over here, you can see on the left, we actually kind of double seed, or we seed pretty heavily because we're so used to a high mortality rate from Pythium. I hadn't even accounted for that difference. So we actually have a very thick stand of spinach there. And again, just showing what happens in that, the detested control plot on my farm that I'm putting my marriage at risk for is looking like this. It still looks pretty bad. I've like hoed it and mowed it and spreading weed seeds everywhere. I did try also calculating the time spent hand weeding and what things look like, you know, just to give some metrics to it. And it takes a long time to weed that chickweed out if you have to actually remove it. I think we're netting about $3.15 on a square foot hand weeding versus the steaming. And then these are rough calculations, but I think we got a much better stand of spinach, less time, less cost. So even though the steamer is expensive, here's my, again, rough calculations. Other people have different ones, but the total steamer and parts was over $6,000. And then the running costs, I was figuring about a couple $100 per tunnel. But when you break it down on a square foot basis, it's actually not that bad. And this is over, I was figuring over 10 years doing 3 tunnels every year. Again, just trying to put some numbers to it. But if we're getting, you know, what did I say, a pound per square foot, and it's costing 18 cents to steam it, it seems pretty reasonable. So maybe I should buy that fancy Sioux steamer. Maybe those numbers work out a little more favorably too. But even you guys know how it goes, like the sticker shock of like, oh, I just bought a $6,000 piece of equipment and what's going to happen with that. So just looking in the other houses at where we transplanted, and Amanda, I can't see the time. So raise your hand if I need to shut up.
You're good so far.
So just between 120 and 140, you can see there's a difference there, and that the edges where the tarp was weren't getting as hot. So chickweed in there. 160 seemed good, but I did notice we had kind of a rookie transplanting our Salanova this winter, and she did this like weird little like dug down too deep and plunked up some soil. So I think we had these like little teeny spots of chickweed right at the base of the plants that I think were because she went below 2 inches deep, pulled up some soil and left a little pile on the side. So now microbes. And this is like definitely the big question for a lot of people is what's happening. You're, you know, as you saw in that temperature chart, you're theoretically blitzing that top. If you're going 2 inches, some people go deeper, those populations. And so in an effort to address that question, I went round and round with what kind of test you could use for this. and worked pretty closely with Deb Neer, a UVM professor with her lab, and a graduate student, Anna Brown, were super helpful with this. And they suggested these things called Biolog Eco Plates, which I think are kind of a layperson's tool in a sense for understanding microbial populations. Now, what it's not telling me is like specifically like which microbes are present at what times, but it's giving like an overall sense of the community profile populations. And the way it works, you can see on the left that little plate with pictures. It has these carbon substrates, and it's tracking the utilization of those by the microbes. So as we know, microbes are eating carbon, and that's what keeps them alive. And with the soil sample we took, they put it on this plate and tracked how much was getting consumed and how quickly it was getting consumed. So I'm not a soil microbiologist or ecologist, but this is my understanding of what we are doing. And it's measuring two things. These plates are measuring the average metabolic response, which is like the respiration rates of these microbes. So basically what that's telling you is how quickly the food is getting consumed and can reflect the overall population numbers. And then the community metabolic diversity is showing the diversity of microbial populations in that sample over time. So Deb thought that these plates would be a kind of a good way to at least start and dip our toes in to understanding what's happening with steaming in this scenario. And this is a 2-year study. This fall was our first dab into this. I have another year to go. So we've only taken a couple rounds of these samples, and we're planning to start April is the next sample I was going to take of these. So early data, but this is measuring that metabolic response. So supposedly overall populations. And the big take home here is the populations crash, as you would expect. We're like, the steaming is at all different temperatures. I'm not seeing a significant difference based on the different temperatures. And then they're starting to climb again around 3 to 4 weeks. So I'm really curious to see what we're going to find in April if they've responded. And I should also say that because of this project, I was like, I actually don't really know that much about soil microbes after many years of farming and working with farms and farmers. So I'm taking Deb's class right now, which is a soil ecology class. And just in the context of that, really understanding that it's these different like questions of soil microbes become sticky and complicated. And in any agricultural environment, you're really just going to have a specific population of microbes that are doing their job. And in the context of like high tunnels, what are we really trying to achieve? I think we're trying to achieve good crops. It's a confined environment. So rather than this question of like the soil health in the big picture, I'm actually kind of honing in on like, what are the microbes we need for the functions of our crops? And maybe that doesn't sound like a very holistic approach, but I'm just trying to like navigate what are we really trying to figure out here and what's the big picture. So the community response is interesting too, because that actually, in almost all the treatments, well, even in all the treatments, that's going up at some point. So why after steaming does the community diversity increase? And Deb suggested that it might be like a successional, like a forest succession was after you like clear out the forest, then what comes back is this like diversity of plants. Or it could just be this different, a different community likes the different conditions that are produced by steaming. There's this altered environment. And so since we're not able to see exactly what the microbes are, we know that the diversity is actually going up, but we just don't know what that shift is and what it's from. So it's a curious question, and interesting that even as the populations go down, the diversity goes up. So not a lot of clear answers here yet, but I think that for me, the longer term issues are really the big question. Like this is right after we steamed, like, of course, things are going to be knocked out. But what is it going to look like in 6 months, in a year? Is there some kind of natural rebound? Who knows? Now, soil nitrate was one I was really curious about, and this is only from one of the tunnels, and I'm hoping to have both of them next year. But we kind of botched that first one, as you saw. And one would expect that as you're killing all those microbes, you get this huge burst of nitrate. Like that's what happens. They have all this, like they're doing all this work. When they die, it's all released into the soil. And that's why after tillage events, like a lot of the agronomic events, you see a burst of nitrate. I don't know what's going on with that, like 160-degree plot. It could be sampling area. It could be that, you know, that house has been fertilized in the past. So not really sure what's going on there. The 140 is what I would have expected to see from all of them. That blue line, they're going up and then going down. And that was kind of the expected result. So we'll have a lot more samples next year, but most farmers, if not all, who steam say they see a crop response to the nitrate that's released. And the timing, I think, works out quite well. If you steam and then you plant, that nitrate is released right when the crop wants it. So that's what we have. Like I said, I'm really interested in what's going to be happening next year, and kind of pairing this with what kind of inoculants and treatments, you know, compost applications, what do we want to be introducing, if anything, into that environment to balance out those microbes? I know one farmer who was on a previous call had said that they felt like some soil-borne diseases got worse, like 6 months to a year after steaming. They felt like what came back into the soil after this kind of wipeout was a lot of Pythium and other soil-borne diseases. So kind of keeping an eye on that. And I'm also curious in the bigger picture, like comparing this with things like anaerobic soil desterilization and tarping and other treatments that help reduce pathogens in the soil. So that's it. I can answer some questions now or pass it along. And feel free to reach out. My contact information's there and Amanda has it too.
Becky, I have a question. Can you hear me?
Yep.
Yeah, this is Bruce with Piccadilly Farm, and you described in your presentation having a hard time getting the temperature up above 130 or so. And tell me a little more about that. You just kept the unit running and the temperature wasn't climbing, or what was your experience there?
Yeah, Bruce, once we got it kind of figured out our area, we were able to get it to 160 pretty easily. It was getting it to 180. That was our big problem. And we ran it, I think, for an hour and a half. And, you know, we were data logging the temperature and it just wasn't budging. And I think it was like, we're trying to go somewhere. I don't know. So that I think I'm hoping is just related to the nozzle size of the burner that we replaced on the steamer, because it seemed like everything else was working pretty well. And our area was just 16 feet by 16 feet, which I think is a pretty good size for us. For the unit we have doesn't do a big area at once. So yeah, our first couple rounds, we were only getting it to 130. And I think we were doing too big an area in our steam delivery. We were messing around with different kind of socks and delivery things. So I really recommend having like it's hard with just like a thermometer stuck into the soil to actually see what's happening with the temperature. So having those data loggers or a thermocoupler really helps to be able to kind of track it in different parts of the tarp. So.
I would encourage you to look at the capacity of the heat exchanger on your steamer before increasing the nozzle size too much, because you can end up burning out holes through your heat exchange unit if you try to go to too many gallons per minute to compensate for, you know, upping the amount of BTUs that you're trying to apply to the soil. I mean, Chris Callahan's calculator is pretty awesome if you have the BTUs, you know, down. And then most of the time we recommend that people who are dealing with different size steamers really stick to not biting off more area than they can chew, and making sure that like you're, you know, it's just physics, like, you know, energy in, energy out type thing. And also your starting soil moisture is good. Yeah, you need to have your soil conditions for that starting soil moisture at the right rate, because you end up with absorption problems and then inverted cooling. And so if you start out too wet, then you never can warm up all the calories that's in that water. If you start out too dry, then you can't get the heat transference into it. And then if you also start out even marginally too wet, then the amount of water that comes in with the steam starts to have evaporative cooling, even though you think you're heating, you know what, but it's actually evaporative cooling under your tarp. And so your heater is fighting the cooling that you're also doing by applying more water through the steam, if that makes sense. I don't want to overcomplicate it, but that's what's going on.
No, those are really good points, Andre. And yeah, I mean, as far as our like nozzle size, I think the one we replaced out was 4 gallons per hour. And so, yeah, I think making sure that we're not like over, going to burn a hole in it. But as far as the moisture goes, that was something Chris and I, when we were building that calculator, we went round and round about, and there's so much cool literature about like the thermal, like capacity of soil and heat transfer in soil. And actually a lot of it comes, I think, from the fossil fuel industry in Alaska, that they've really thought a lot about that stuff. But yeah, we irrigated before, like lightly before steaming. The other thing we ran into, and I don't know if you have advice about this, Andre, was our water is really cold. So the water we were feeding into the steamer was really cold. So when we had to replace the water, like when the steamer called for more water, the temperature would drop. So we ended up leaving a hose on like a very low trickle going into the steamer so that we weren't ever like offering this pulse of super cold water. But I don't know if we should be pre-warming the water before steaming or what, but that seemed to really knock us back.
All of the units that, I'm sorry, it always stinks to have the video off of the guy talking, but all of the units that I've dealt with have auto feed on their water. And so we just put the constant feed line, and the temperature of the water has never really had that much of an input. The water goes into, essentially a flow chamber next to the thing, and then is fed in, just as it needs. I've never seen in any of the units that I did a huge temperature drop inside the unit as more water was applied. Kind of speaks to the efficiency of the unit. And, like you had mentioned, you've purchased the old tobacco equipment. I think a lot of us start that way, but when you get into the more designed units for exactly what you're trying to do, you see how short your unit is? You'll see that they actually get longer or fatter. So like they have more coil. So it's just more distance to do that exchange in. So I think that might be part of your problem there.
I just want to take a second to encourage folks to please do put your questions in the chat. Jeremy's collecting them for the Q&A that we're going to have shortly after Bruce shares a little bit more. But I just want to say thank you, Becky. That was excellent. And we look forward to hearing more from you when we carry on with the Q&A after we hear from Bruce.
Thanks.
Bruce, can I hand it over to you?
Thanks, Amanda, and thanks, Becky, for that presentation. And I think I'm going to join you in the spirit of being a beginner or an advanced beginner in this process. We're learning a lot, and it might be interesting to make this Zoom conference sort of an annual event. I bet even just after this next season, we'll all have a lot more that we can say and contribute about fine tuning. So to those of you who are brand new at this presentation, we're not too far ahead of you. So hope that you will be either enthusiastic about joining us in that spirit, or else maybe you want to wait a year before you dip in. But I am a vegetable farmer at Piccadilly Farm in the southwest corner of New Hampshire. And so we're in the Cheshire County Conservation District. And a lot of our farm includes field crops, but we do have several high tunnels. and we're enthusiastic to do some steaming in our tunnels. And we are also a host farm for the steam generator. So the generator that was purchased by the Conservation District lives at Piccadilly Farm, and then those who will be renting it out will pick it up here, take it to your place, and bring it back. So we got delivery of the steamer last late October, and had the chance to do one trial run with 4 or 5 people. And what I want to do is switch over to a video that kind of shows some of that run and some of our activities and lessons learned. So here we go. So what I want to do is play this video first, and then we can go back and talk about it a little bit. Okay. So that's what we did, and a couple of things I want to just talk about while I have this picture that shows the unit to describe things a little bit more for everybody. First, in order to steam, you need a water supply and an electricity supply that doesn't come with the unit, and you can see there's a garden hose connection right there where my cursor is. And this hoop house where we were doing the steaming is a little bit away from the farmstead out on its own. There's no electrical service or underground water hookup there. So to get the water out, I was just running our irrigation pump, not pictured in the screen, but I was able to get the water out that way. And it comes and hooks up right here. And you want to be able to supply several gallons a minute at about 40 PSI for this unit to work right. But what happens is after initially filling the whole tank with water, that steam gets generated from that water and goes out through the discharge pipe. So you need to be adding water back in all the time. And there's a black water feeder valve pictured right here that automatically gets the right amount of water in based on the amount of water that you're drawing down. You just have to have the hookup. So that's one thing you're going to want to do. And you're also going to want to have electricity. And it's just a regular household current, 110 volt, like you'd use for a kitchen appliance or a computer. And so we just borrowed a generator from a friend. It's off the screen over here. And then we connected our electricity that way. A couple other things in this picture. This steam generator has 2 discharge points back here, and they're just these faucet valves right here. So you can open and close those valves, and that's going to influence how much steam feeds out into the steam tube right here, which goes to the sock underneath the tarp. And on our particular unit, we're set up with 2 of these discharge points, and it gives us an opportunity potentially to hook up 2 socks, which could either mean 2 socks were steaming under the same tarp, or you could be getting a second tarp ready while the first one is in use. As you can see, we aren't able to steam the ground in a complete hoop house, which might be like a 17 by 96 or a 30 by 96. It seems at best we're doing something more like 5 feet by 96 or possibly bigger than that. So each tunnel is going to require a series of runs. And after you finish a run, it's going to take a little bit of time for things to cool down so you don't burn yourself when you're moving tarps, moving chains, and things like that. So one of the things we look forward to playing around with is setting up a subsequent run while the first run is still cooling down, just to save on the overall time. So for the trial that we did, and thinking about some of the variables that Becky was describing and Andre were describing with the steam calculator that Chris Callahan from UVM put together, how moist is the soil tilled, things like that. And it does seem like it's a little hard to measure exactly what soil you have if you're just a farmer, what moisture you have if you're just a farmer pulling up to your hoop house and you sort of put your hand in the soil. I think that it wants to feel moist, like you're not saying, oh gosh, I need to irrigate here, and you're not saying, wow, I just irrigated and it's pretty wet. It's just kind of that sweet spot of you've got some moisture in there, and then that's going to allow the steam to percolate through in the most efficient way. And in our case, for that trial where we did the video, we did not till the soil ahead of time, and that tunnel had tomatoes in it over the course of the summer, and we took out the tomatoes just by uprooting them, and we hadn't done any extra tilling. So we had more friable soil right where the tomato rows had been, and then more compact soil where the walkways were. In that trial that we did, a couple of things. One, we had trouble getting the tarp to stay inflated and have a nice billowing cushion up above the ground. And we also found that it was taking us a long time to get up to temperature. I think we only got up to about 140 degrees, and we were running for about 4 hours. And in the steaming calculations and all, it seemed like we should have been there in 2 hours or less. It was November, so the ground was colder than I think it will be in August or early September when we're steaming before winter production. But we did have some question marks about, why did this take so long, and what might we want to do differently? When we started that steaming trial, the tarp was wider. We were covering about 8.5 feet. I was thinking, okay, we'll do half the tunnel in this run and then be able to do another run for the second half. But as we had trouble getting that tarp to inflate, we narrowed down to about 5 feet, which is a dimension I think that Andre is a little bit more accustomed to with the steaming that he's doing. I did look at a soil steaming video that's part of the promotional stuff from the Sioux Corporation, who we bought the unit from, and they were pretty happily steaming about a 10-foot by 96-foot area, and they had a nice billowing cushion underneath their tarp. So it all points to just a few more lessons to learn as we get dialed in exactly with what's going to work best. And also, it's interesting that it may change a little bit as we go from farm to farm. If you have a heavier clay soil in your tunnel versus the lighter sandy loam in the tunnels where I am. So there are some things to figure out, and it may mean that our first couple of rentals are going to require a little bit more time. It might not be that you can just get the unit over to your place and figure, okay, I'm going to have 2.5 hours per run. I'm going to do 3 runs and I'll have my tunnel done in 1 day and I'll bring the trailer home the next day. We may want to set aside 2 days just to sort it out. And there's another detail about that steam and the steam delivery. You can adjust on the generator what window of steam pressure you're trying to discharge. And we were going for about 9 psi in that trial video, and the unit is capable of going higher. So we may try and goose it up a little bit to somewhere between 10 and 12 and see if more steam pressure gets us up where we want to be more quickly. So does anybody have any questions about the mechanics of the steaming at this point I could talk about?
I'm not seeing any in the chat, Bruce, at this point.
Well, what I can say about the steamer here, we are planning to use it in the fall at our farm to get some tunnels ready for winter. And I'm looking forward to playing around with the width to see if we can do 5 by 96, or we could do 10 by 96 to see what a good area to steam at one time is, and then playing around with the socks. We do 2 steam socks under the same tarp, or we can flip, getting one ready while the first one's cooling down. Those kinds of things. So that's where we're going. And then I'll also be able to be a resource for people who rent out the steamer and take it to their farm, and see if I can help you guys get dialed in for using it well at your place.
Bruce, we do have a couple of questions that have come in if you want to take them now. One is just about the fuel being used for the unit. What type of fuel are we using?
Yeah, this unit is set up to run on either diesel fuel or kerosene. And I assume that biodiesel could also be used, but that would be something worth probably double checking with our rep over at the Sioux Corp, unless possibly Andre knows. But it is diesel. It can be on road or off road, and the tank holds about 65 gallons. And so the burner on this unit is, I think it's a 4.5 nozzle size, so it's going to use about 4.5 gallons per hour. So with a full tank, that's going to give us about 15 hours of steam time.
Okay, Bruce, and then there was another question about the materials that come with the steamer, asking specifically about the tarp and chains and whether or not they come with it. Also, I'll throw in there the temperature sensor and moisture meter. Are those part of this?
Yeah, so yes, we do have a tarp and chains, and those come with the unit. And just before our trial run there last fall, Amanda picked up a couple of temperature probes. So we have 2 probes. It's a meat thermometer, really. It's got 2 probes and then a little gizmo with a digital display. And so you can unplug the display from the probes. So we put probes in 2 places, and then we could take our meter and go back and forth between each one and see how we were doing. And so still somewhat of a low-tech approach, but I know we could easily include that with the rental. And then there may be people who do some more careful and precise temperature measuring too, as we sort of get it all dialed in. But yeah, a couple probes could come with. And as for the soil moisture, we don't have a moisture meter set up. It's still a little bit of an eye and a feel for getting yourself to be what you would say reasonably moist, as opposed to either dry or saturated being the window that we're trying to work in.
Bruce, I'll just chime in there quickly and say that we have a fact sheet through UNH Extension about using soil moisture sensors, and I don't know if they're rated for the temperatures that we would see underneath the tarp or not, but some of those moisture sensors are pretty easy to use and relatively low tech. So that might be something that you're interested in for your farm anyway. And if you did have those, they're able to give you basically soil moisture in a format that would also help you with irrigation. So we might, maybe we'll try it with one that I have and see how it stands up under the tarp first and make sure nothing melts or comes apart. But they are rated to withstand winter temperatures, and I know that they can take the cold, but I'm not sure about the heat levels that they're able to take.
Jeremy, they wouldn't have to take the heat because the important time that you need to know the moisture is prior to steaming. And so if you have if you've achieved good moisture, then you could take the probe away and steam and then put it back. So you don't need to endanger the life of the probe.
There we go. Bruce, there was also a question about, can you share any of your results at this point? Have you had enough time, or is there anything that you want to share about, how things looked after the fact?
Yeah, that's a good question. And actually, that steaming run was basically just sort of a demo. Let's figure out how this works and see if we can get a little bit of footage to share. So I did not plant in that ground after the steaming in November, and it's just it's sitting there dormant. So nothing has really happened, and nothing's really sprouted in the steam area. Nothing's really sprouted next to it either. It's we've got the plastic all rolled up. It's basically just been outside for the winter. So no results to share there yet.
Okay, and then there was just one question about the timing, asking why not steam in spring? And I know in this case it was kind of a trial to get familiar with the equipment, but can you speak at all to timing and when you would normally do this and what your goals would be with targeting weed control, disease control with crops?
Yeah, I think timing depends a lot on your crop production and what you're up to. So it would be fine to steam ahead of a crop in the spring. Let's say you're going to be planting tomatoes. One of the a lot of the enthusiasm for steaming right around the fall is to steam before you do winter greens, in particular for the chickweed, as Becky was pointing out. If you're steaming before tomatoes, that might be more enthusiasm for disease control than weed control, where a lot of growers are using plastic mulches or straw mulch. They've got a lot of covered ground and then shady ground level conditions. When you do the steam and you're getting that steam penetration down into the top 2 inches, you can see, and Becky pointed out in one of her slides with the lettuce transplants, that they brought up soil that was outside of the steaming range and then brought up some weeds that way. So the idea is to get your beds just completely ready for planting. And so all you do is you go and you steam, and then you're not going to be disturbing the soil profile after steaming, just the minimum that you need to do the planting after that, to keep the benefit of your weed-free soil all right there at the surface. There are other applications for this steam that we're all considering, and I know that there's enthusiasm for in the Conservation District, besides just steaming ground for high tunnels. And it could be that you could steam some field ground or a place where you're getting ready to seed a new pollinator habitat. Again, you have to figure out what area can you steam at a time and how that works. But there could be field applications for this besides the high tunnel applications. And something else, I think Andre may also have a little experience using steam to clean containers. So in farm production, if you're distributing produce for various wholesale or CSA customer outlets, you can then steam clean some of your containers. You could also steam clean seedling trays for propagation. And those require basically setting up a container or a small room and getting the steam rigged up that way. So we're at the tip of the iceberg here. Andre, do you want to chime in with your experience based on steaming at either different times of the year or other applications?
Yeah, I mean, I think that your point about the containers is awesome. I mean, one of the things that we did this time last year when we moved to immediate home delivery, we were delivering we were delivering to people in, bulb crates, which, a lot of farms use bulb crates for everything. But we didn't know much about the virus at the time. And we were like, we have to make sure that we are, having clean surfaces. We had heard that like, oh, it sticks to cardboard, everything else. So we got these plastic liners and threw them in the bulb crates and packed people's orders in those. But then they would come back, and we were like, okay. So we could run them through the AZS rinse washer, but like, how sterile were they? They were clean, but were they sterile? We didn't know, So we stacked them right up in the back of a box truck. Took a mat, took the steam hose, put it in there, temperature sensor, brought it up to 160 degrees, held it there for 20 minutes. And that's pasteurization right there. I mean, my wife's a cheesemaker. I got the numbers from her. She was like, 30 minutes at 160 kills everything. And I was like, okay. And then if the cheesemaker says it's so, then it is so. But then we, because we did it in March, then we did it with like our used, 98 plug and 72 plug trays. And, we have 128 trays and we have 1 million of them. And like, I've always wondered how much disease I was transferring from one to the other, but we threw them all in a container and sterilized those and like had incredibly different results of like, not having that random tray that like nothing grew in that tray this year. And so that kind of went away. So that's an added use for the machine. I will encourage people that like when you're dealing with plastic trays, the steam will melt the tray. Like if you're not careful about the source of the steam, like the area that comes out, like anything in that area is just going to melt. Like it's going to be much hotter than 160 degrees. And so just to be careful about that. That's another thing about making your beds beforehand, Bruce. Like we make our beds, we have guidelines so that we don't walk in the bed while we're doing it. First couple times we did it, we used plastic tent stakes. Bad idea. Plastic tent stakes melt under the tarp. So we moved to metal stakes. So like that's a learning thing. The other thing that I noticed with you is you had your sides rolled up. And I also noticed that you guys had some pretty warm clothing on. I think you'll be really surprised about, there seemed to be a breeze, the cooling effect across the top of your tarp. We don't steam anything unless the thing is shut tight. We actually preheat the house for a day. We're starting with soil temperatures that are around 60 degrees minimum, even in the colder part of the year. So that is a really big head start over where you were. So I would, in the chart, I think Chris has a starting soil temp. And I don't know what your starting soil temp was, but it's the delta T that you have to worry about, how much you want to climb in that area. So the more that you can preheat soil to lower your delta T, the better experience you're going to have with steaming. And then we just came up with some efficiencies. We built a manifold. I know we designed one for you guys, but I don't know if you guys purchased it. But we, with one steam line, can run 2 lines per bed. And I'm running at 5-foot wide beds. And if you run 2 steam socks, you're getting a more even distribution of steam across the entire surface of the bed. It lowers the amount of time. And so like my initial machine was a lot smaller than the one that we had. So, but with the machine that you have, I would say you could do a 5-foot by 96 thing. And if it was a 2-hour total run from heat up time to holding for 30 minutes at 180, I would think that would be about the proper amount of time it should take to do what you were trying to accomplish. I think you're right in thinking that like taking up more and more space of that might be problematic, might be biting off more than you can chew. But yeah, with the proper soil prep and then pre-warming, and then also not having any kind of cooling factors like their sides rolled up and like some breeze and that kind of stuff really does start to take away things. You have to start thinking like a calorie, and so heat is calories. And so like what's pulling your calories away, and how can I conserve that?
Andre, it sounds like you're advocating running 2 socks even in a 5-foot space.
I do that for just efficiency and time. Like I can lower my time considerably on a run. It's making enough steam in the unit that you guys have. The problem is that with 1 sock, you can't distribute that steam over area fast enough. And so you can lower your steam time drastically if you can distribute the temperature over an area more evenly. So the machine has no trouble filling up those socks and distributing the steam. That's all coming out. It's a matter of, so it's producing volumetrically enough. The problem is the distribution. So how do you distribute steam better? I think if you go up to, I think Becky might have seen, if you go up to Krista and Mark's farm up Jericho Settlers Way, I mean, Mark melted many a tarp because he just wanted to get as much steam into the beds as possible. So he doesn't use a sock. He's just like pumping steam out the end of the hose and blowing it into the area. And he gets really great coverage and he can do huge areas because it's just free flowing steam out of there. But he also tends to melt holes and things with his unit that way too. So that's not exactly the handiest dandiest thing, but I think that there's something to be said for the unrestricted thing. The other thing is like I said, like back in the late 60s, early 70s, they used to do perforated socks, and everybody got away from that because the socks that we use now are mainly used in the petroleum industry. That's like what we're using. We're using petroleum industry technology at this point because methyl bromide came in, displaced all the steam. Now we're all turning back to it for strawberry production and stuff. There's many of these different walking units and stuff for outdoor production, which are amazing to see in California for strawberry production. But now I think in the next 5 years, you're going to see the reintroduction of the perforated sock back. And that's just basically a ability for more steam to come out of the sock instead of just like kind of leaking out of the woven fabric of the stock. And so you're just like delivering more quicker. But yeah, I mean, the wider the bed you go, I think that 2 socks become more and more important. The narrower you go, I think that you can get away with the 1 sock pretty easily. I don't know if you've done this experiment years ago, we had the temperature probes lined up across the bed, and so it was like the seam stocks in the middle. What is the distribution of the heat? And we were like, you have the hot spot in the middle, of course, because that's where the thing is. But then the second hot spot is actually like 5 inches away from the edge of your chain, because that's where the steam is getting closer to your soil. Because if you have a bellow like this, steam is compressed right before the chain. And so the closer you get to the chain, now you're dealing with the temperature gradient of the soil outside, but there's another spot in there that's like wicked hot. So these are the 2 spots that I always avoid putting my temperature thermometer probe in, because I'm getting a false hot reading as to where I want to be. And so if you're looking to get to that 180 degrees, you don't want to be measuring right next to your sock or right near the edge. You want to be measuring in about, depending on how wide the bed is, but my beds are 64 inches or so. So like I'm measuring a good 8-9 inches off the chain in is where my probe goes. And that's giving me a more accurate, like maybe reading. Also, you probably saw that the back of your bed and the front of your bed, obviously it's pretty obvious that the front of your bed, that's where the steam is the hottest. It gets there first, everything. Well, you forget that like the back of your bed is where the sock is tied off. Steam tends to collect back there. Taking temperature readings from the back of the bed is also giving you a false reading because it's hotter back there. I don't know if Becky, you saw this in your things, is like you had really great control for the first 12 feet and the last 12 feet of a bed if you're doing a 100-foot bed, like, and then as you get towards the center, like you could start to have control issues, damp off issues, things like that. And so that's saying that you're not getting even distribution of heat.
Yeah, those are great points. We did see a lot of that, and I ended up sticking in, I think, 4 temperature probes all over just to see, and it was really different lines based on where the probe was. So trying to figure out, like you're saying, the best spot to get a good reading. And just on that sock thing too, like I was like so confused about what kind of sock to use and what to buy, and thought we needed a perforated one. And there's someone in Denver that makes like custom, like we were worried about like plastic too. So we were like, oh, we don't want plastic. It's like a really expensive grommeted handmade sock out of this place in Denver. We decided not to buy that, but we did end up getting that dental sterilization tubing, which I think is like kind of because then you can custom perforate it yourself pretty easily, and it holds a lot of steam. And you could do multiple like tubing of that. This place in Japan had a pretty cool setup with that. And then David Pock from Sassafras Creek Farm, he is using that hydraulic hose material from like hydraulic lines on tractors, and got like a fatty of that. And that seems to be working well for him, I think. So
I think he only uses that to deliver the steam from his generator to the bed.
Okay.
That's not what's going down the bed.
Okay.
And I actually believe that a very similar material was delivered to you, Bruce. It's not quite hydraulic line, but it's a heavier duty than the first generation, which is what you have, that lighter duty black tubing. That I think Bruce is dealing with more of a woven kind of the walls are reinforced on it, like the hydraulic tubing you're talking about.
Cool.
Similar make.
Yes.
And I ended up like Mark talked me into just blowing the steam in without any delivery when it came down to it. Mark was like, why do you need a sock? So
because Mark was brought up by Jericho Settlers Farm. That's where, they went up there, drunk a bunch of beers and played with diesel run equipment. And, that's what ends up happening. Yeah.
Becky, can I ask on the dental tubing, what's the diameter on that? How big is that stuff that you're using?
You can get whatever size you want. I think we went with like 2.5 or 3 inch. And then for the stuff we used for weights, I think it was like 1.5 or 2 inch, and we just filled that with water. And you can kind of, those like little snake things you used to play with when you were a kid, like the water filled, like it's just like that. Okay. But it was a lot easier to move around than chains. And like I said, we were like super like scrappy in terms of like investing in things. So I don't know.
Yeah. So I just want to see, like, do we want to like kind of officially transition over into the Q&A session? We do have a few questions that have come in, but I want to make sure, Bruce, that you've had a chance to say everything that you wanted to say in your session, and make sure you don't have any kind of closing remarks that you want to make, Bruce, before we transition over to some of the questions that have come in.
Thanks, Jeremy. I think we're moving pretty well into more Q&A. I can say for the trial in the video that I showed, our starting temperature, Andre, was 46. So it was a chilly start.
Yeah, I think I love starting to steam the first week of October. It's a huge difference in October around here. Like the beginning of October to November, I do my last houses in November 1st. And there's a huge difference in performance across the month of October because of that. Shutting the houses up tight and everything. But like in the beginning of October, I was just looking at my data. At the beginning of October, we're starting at almost 80 degrees, the soil temperature. That's a huge amount of caloric intake that we've already gained by solar that we don't have to gain by diesel fuel and generating it. So I'm 35 degrees above your starting point just to get going, and then also the house is sealed up tight, so there's no cooling effect on the tarp on the outside. So that
kind of ties into one of the questions that we have related to our target as far as how deep we want that steam to go into the soil. Kind of assuming that we only want to run the steamer for so long in one spot, both for the cost of running it, but then also, maybe impact on soil ecology as well. Realizing that steam's only going to go so deep. The question is kind of about how tillage is being handled in tunnels in consideration of weeds, minimizing bringing those back to the surface, So just thinking about when we do steam, how deep is that target area? And then what are folks doing to minimize bringing weed seed back to the surface?
Can I ask a question, Jeremy? I don't know if you know more about the details of this question, but it's highly dependent on crop. I mean, Becky, Bruce, and I are mostly steaming for a winter weed problem. I have steamed a couple tunnels to really kind of rogue out some tomato soil-borne diseases too. And then I consult with a separate company on doing that for flower growers as well as tomato growers. And they all have different parameters and depths. So knowing what crop we're talking about would be really prudent to answering the question correctly.
Sure. Yeah, and I think just really from your experience in the crops that you're utilizing it on, I understand what you're saying as well. But in general, you know, is our target range for, say, the greens, you know, if you're doing fall greens, you know, that top couple of inches. And then, you know, Becky mentioned the transplant planting and how that may have brought up a few weed seeds around. So I'm just curious, you know, if your tillage practices within the tunnel have changed along with, you know, adopting more steaming in your operation.
I mean, most of the recommendations for like what we've been talking about today, I've read is 2 inches. And then like Andre said, I heard from a couple flower growers and they are going quite a bit deeper and quite a bit hotter. Like I think getting right up to 212, right, Andre? Like 6 inches.
And some flower growers are going down 20 inches, which is like insane.
Well, I think the bulbs, there's like a problem with bulbs, soil-borne diseases for bulbs, and they have to plant those quite deep.
Yeah. Yeah, the tomato growers are going 9 inches, flower growers are going up to 20 inches, but most of the greens production, if you're doing a 2-inch penetration, it's really hard for a weed seed to come up above 2 inches. And the other great thing, and I think Becky's later biological numbers are going to show it, for the greens production at 2 inches, like our living soil in our greenhouse is, you know, 9 to 12 inches deep, which is probably deeper than our, like Bruce pointed out, is like inside is different than outside. So we've got a living system in our greenhouse pretty deep because we're managing for a biological system in there, and it's a small area, and, you know, might as well be potting soil or something, you know, but so there's space for the biology to come up from and repopulate if you're only going down 2 inches in an enclosed system like that. If you know, the deeper you go, the hotter you go, the longer the recovery time for the biological system to come back. So much so that like certain you know, growers that are highly dependent on steam in closed systems actually have a re-inoculation program as well, where they're inoculating the soil with a, again, this is really credit to my wife, the cheesemaker. I'm like, how do I handle this? When you kill everything in the milk, if you want to make cheese out of it, you inoculate the milk with the right thing you want. This is the opportunity to inoculate with the correct mycorrhizae fungi, some favorable bacteria, and you want them to be out competing the situation where you might have made pathogens a preferable thing. So like, it's just like out in, you know, how we try to treat our biological systems out for pests, like for a bug. You know, we go out there and you annihilate everything with like Warrior 2. The first thing to come back might not be your beneficials that are gonna, you know, eat your Colorado potato beetle larvae. They're gonna be some, you know, the Colorado potato beetle larvae are gonna be like, thank God all the predators are gone, let's have a party. And that can happen in your soil too. And so the idea, I'm intrigued by the idea of re-inoculating with the right mix of things so that you have a good balance of that.
Great. So,
Go ahead.
Becky.
I was just also going to piggyback on that and say that's like my hopeful assumption too, is that things are coming up from down below. And I'm kind of curious, like if you're getting 180 at 2 inches, how deep, like is the temperature raising enough to kill, because we saw like some of those lower temperatures do take out like the nitrifying bacteria. But also like a big kind of light bulb moment with this class is like a lot of those microbes are dormant unless there's living roots anyway. And like 90% of the action is happening around living roots. So if you're steaming, like if there's been a period of dormancy, you're steaming and then you plant, I think things are going to migrate, especially with a transplant in a compost potting soil. I think you're like in pretty good shape. So I'm curious about that difference between like a transplant versus a direct seed, because you're just bringing in, you're inoculating it if you're using a compost-based potting soil. And maybe you put some trichoderma in there too. I think you're, I'm like hopeful that it's gonna look pretty good.
I would also say your visual observation of the like getting chickweed control at 140 is something that I've been playing with for years. And I didn't want to say this out loud here because I don't want to lead anybody down the wrong road, but I don't go to 180. I go to 160. I've even tried to have my goal as 140, and 140 is too cold. I'll tell you that. Because temperature drops pretty fast actually as you go down. But I had the same concern that you did, is like, if I'm at 180 on the surface, what am I, like, how far down am I killing everything? And so I made my goal 160 at the surface for 30 minutes. And it's been serving me okay. It's not in the literature. It disagrees with things in the literature. So I'm waving a huge opinion flag here. This is like totally Andre's like shooting from the hip thing, not like to be taken as gospel at all. But that's what I ended up doing, because I think your observations in those slides kind of prove what I was doing, anyway.
Well, and also I think I'm also coming around to 160 because to be fair, like the 140 plots aren't looking as good right now as they did when I took those pictures in January. So I think the control is like, and maybe all you want is that window to get your crop planted, harvested, and then you're steaming every year, so it's kind of, but I think 160 is kind of seems optimal right now. I don't know.
Is anybody steaming more than once a year?
The research I've done doesn't show any like of us practical people, but there's actually some really good evidence that a double steam is like amazing 100%. So you like steam once, wait a week, steam again, and you're getting like really, really amazing control on pathogens and weed seeds. So something about that double steam, like in sequence, but who's going to do that?
All right, so we had another question that came in. It was related to, I think really weed control. It had to do with the use of horse manure and whether or not steaming horse manure would work to kill weed seeds. How about manure-based pathogens, which limits manure use in food production? Sterilization versus pasteurization, question mark. Maybe this is another question for your wife, Andre.
Yeah, cheesemakers love to be far away from the cows, I'll tell you that. We are working with someone that has a project right now that they're windrowing horse manure in these shallow windrows, and they're asking about doing steam injection into that because of the weed seed problem. And so this was one of the reasons that like I was thinking about the vacuum line. Doran Cox is he's always coming up with these amazing ideas. He has Tuckaway Farm up in Lee, New Hampshire. He's a very kind of low tech, high tech guy. And he does these stagnant composting piles with tubes in there so that you don't have to turn them, so that he can inject the air into the system. And so we're going to experiment with creating a positive pressure in his tube to inject air into the system of the horse manure and bedding. It's not just horse manure, there's bedding involved. And we're going to try putting steam through this system and have it come up through the pile and see what kind of controls that we can get there. It's really like package deal because he has the windrow, the tube in the bottom, and it's tarped. Like, so I don't know how much better of a pre-set up situation. So stay tuned and we'll let you know how that goes. Yeah.
Awesome. Yeah. And so, but in theory, like if someone were applying horse manure to the surface of a bed and then steaming, then it should help to control the majority of weed seeds that were susceptible at a certain temperature, you know, if folks were doing that, correct?
That would be correct, except that you would have to be grossing under $500,000 a year to get away with it, because that's no matter. I don't think the FSMA doesn't allow for a like a treatment. Like they have a biological base. I don't want to get involved in this right now, but like you extension people could probably elaborate more than me. But there's a biological use, and so they don't have that. It's that you can have a practice that cures that. In FSMA, like you apply it and now you're 90 days. Doesn't care. So basically, if you could circumvent that, Jeremy, then you would be speaking factual information. Is it legal and practical? I do not know.
Right. Yeah. I guess with the timing, you know, that type of an application wouldn't really work out. But what you were describing with the windrows would be, you know, a practical application of that would move towards, you know, that end goal with hopefully those food safety considerations in mind as well. So we had another question. We have a few that have come in. Let's see. Could you add PVC pipe with holes or something like that to the compost piles to heat the pile? It sounds like, right. It sounds like that's the idea with that, right? There's going to be some piping and ventilation there so that that air has a place to flow and move throughout the pile or the windrow.
It's a leach tube.
Yeah.
It's a leach tube.
Okay. There was also a question about the steamer unit and whether or not there's any sort of a handheld wand or attachment that can be used for field applications of steaming.
There's not with this one, and because it sits on a trailer and it's a fairly heavy unit, you kind of want to put it in place with however you're moving it, with a pickup truck or a tractor, and then you've got to get your electricity to it and your water to it. So it's not quite something that would be that portable. It does have this discharge hose, and if you could attach a wand to that, you might be able to, you know, do an area right around the steam generator, you know, up to about 100 feet or so. But it doesn't seem like that's where the money is, trying to get some sort of a handheld wand that you would move around with.
Let's see, there's a question also here about whether or not anyone has noticed any physical soil changes after steaming. You know, like thinking about you know, soil compaction, or, you know, whether drainage has been any issue, anything like that you've noticed changes in post steaming.
I was actually going to mention that something is you really don't want to walk on the beds at all after steaming, because it really, like, it changes the aggregate structure, and I think it's like you know, it's penetrating all those aggregates, and so I think you're sort of crumbing the soil. I don't know if you guys can interrupt me, but it really compacts a lot after steaming, and I think walking on it is like, seems incredibly, like, you know, so that's my take on it.
So there was also a question related to kind of cost, and I know that Becky shared some good information on her net, you know, the net value, or the net earnings from, you know, steamed versus unsteamed. Andre, I didn't know if you wanted to kind of share anything in your experience based on that. I know I've seen some charts in the past. It seems like you're in the camp of it's certainly worth it, and that you get quite a bit of labor savings going forward through weeding,
Yeah.
sorting through the crop, that type of thing.
So my numbers are about $100 higher per 30 by 96 than Becky's, which could have been a couple variables. We depreciated the machine over 20 years. And this is like we depreciated the machine over 20 years because that's a general lifespan of the heat jacket of the machine, and figuring that you could sell it at a depreciated value off at any time after that. So that was our assumption there. And then we assumed some price. So we're at like 600 to 625 a 30 by 96 house. And I think, Becky doing a couple feet of hand weeding can show you pretty quickly those numbers. That it's well worth it. If you're a winter grower, though, it becomes worth it because the chickweed gets so bad that it's not practical to grow. So basically, you like, not only is it be hand weeding, but you basically have you get to the point where like you cannot grow without some treatment, something. You have to do something. And so I tell all the new growers that I consult with about winter farming, I'm like, yeah, the first 5 years are free because you don't have any problems in the first 5 years. Like, you're not accumulating those things. But I think Becky's data that shows you like the different seeds and like how those chickweed seeds can get away from you pretty quickly. It's taken me years to beat back the seed bank from some of the vicious problems that I created for myself. Now, that being said, at this point, I don't have to steam every tunnel every year anymore because I just don't have the problems. And then I see a few hot spots come up and I'm like, I'm going to steam this tunnel next year, and that's changed everything. Now I'm managing 14 winter tunnels at this point, 14 30 by 96 growing areas. So it would be not practical for me to steam them every year in a timely fashion. However, they would be unusable without it. So $600 investment when a tunnel full of spinach, we grow spinach a little differently than, okay, it's a little bit more intense because we actually have machine harvested stuff. But so we can do like about $20,000 in a winter in a 30 by 96 retail value of spinach. So $600 investment versus making that space unusable is a pretty easy calculation for me to make.
Yeah, and that's 10 years in, right, Andre, to the process. And so folks would expect to kind of get a handle on that and start to be able to refine their schedule based on observations and those hot spots a few years in, maybe by year 5, you're saying, and then start to make individual decisions about tunnels that need to be treated or not treated going forward.
And I think that one of the things that Becky's numbers are going to show in a few years and that you should be careful with, and like there's good data out there just to read about, is like, what are you using for fertilizer throughout the year and steaming? Because it will correlate with, like, you could basically turn a lot of stuff to ammonia as well with steaming. So you cook your nitrogen into ammonia and then you volatilize it all when you take off the thing. So you might not, so I think it'd be interesting to like soil testing and stuff like that. So steaming is like, if it's going to be a management tool, I really am enjoying and want to learn more about, like, I'm more observational and Becky's doing the real work of actually counting things and figuring it out. So it'd be neat to see some soil tests about, like, not only the biological, but the mineral parts. How much nitrogen are you volatilizing during the process? And what is the parent material? Are you using nitrate? Are you, what is the parent source of the nitrogen? And then also you have the other problem inside of a greenhouse area is that we're all worried about salt. And so we're all doing saturated medium tests to make sure that we're not basically salinating the place. And so I think that if you are going to be a soil steaming, farm, you need to actually really make sure you're on top of your saturated medium tests and that you're monitoring for the fact that like you're managing salt. And so you don't want to turn your farm into a salt flat either.
I can, Jeremy, if there's time, I can tack on to some of that.
Yeah, absolutely.
I just want to also, what Andre just said about costs is really important. And I think, like it was so clear. I mean, we had like kind of lost 2 tunnels last year and this year, like, the numbers I like with the farms I work with, like easily 20 grand a tunnel, and, like between 10 to 20 grand a tunnel, but depending on what you're growing and who you're selling to. And that makes $600 seem like nothing. And also it's allowing us to switch to mechanical harvest. So we are like going to like a more solid planting, more dense, and buying a mechanical harvester. And we've never been able to do that before because of chickweed. So it like allows you to scale up, and then I think that's also an excellent point about the nutrient management in the bigger sense. And part of why I'm interested in this project is like trying to get this comprehensive kind of nutrient management for high tunnel in together. So I'm working a lot with tomatoes, but like I said earlier, it's like, oh, we're telling people to put all this like nitrogen on for tomatoes, and what happens at the end of the season. So there are a lot of concerns about ammonium being toxic to, if you plant right after steaming, there's some evidence you could have like ammonium die-off, I think. And also luxury nitrate uptake with the crops. I know there's like been concerns in the past about winter greens having luxury consumption to toxic levels of nitrates. And, it's funny because Vern, I asked Vern about that, and he's like, well, there's not that much evidence unless you're feeding a baby a smoothie with spinach in it every day. And I was like, oh, I was like, I've actually been doing that for like a year, Vern. Oh no. So I don't think like there isn't a lot of like actual consumer concern there, but it's just something to pay attention to. So how we're cycling the nutrients through the system, I think, is really important, and what the steaming is doing. Like it's related to the microbes, but really what we're interested in is nutrients, right? And like I said, like a profitable crop at the end of the day. So
is that something that your research is going to take into account as well, Becky? Are you going to be looking at, that nitrogen usage and nitrates and that type of thing as well? Or are there other folks that we should have on our radars to follow their work that you know of?
That's a good question. I mean, like I said, this is kind of a low budget study. I'm taking nitrate tests and have an ammonium number attached to that. I hadn't thought about taking tissue samples. I guess I could. I will be taking tomato tissue samples all year. So that's, we're planting now tomatoes, so we'll be able to get some sense of that. But no, that's a good question. Maybe next year we can tack that on.
Great. It's going to be really interesting to follow your work and see what comes of that. I think we're getting close. I want to open it up. So if folks on the call have questions that have been stimulated by the conversation, feel free to unmute yourself and just ask the questions directly to the group here. We do have a question, and Andy, maybe you'll get to this and wrap up, but it asks us to talk about the rental process with the Conservation District cost and that type of thing. So are we going to cover that before we wrap up, or do you want to touch on that now?
Yeah, thanks, Jeremy. I think, Amanda, if you'd like to maybe share a little bit of information about the rental program and related to the steamer, I think now would be a great opportunity.
Great, thanks. So we're excited to be able to make this available and affordable for farms to be able to try out in the region. And so for the first few years, there will be no cost for farmers to rent the equipment, because we've discussed this sort of with our board and the equipment committee, which is made up of farms, And it's a learning process that we're all in, and we want to be able to make sure we sort of can learn how it works and have farmers be able to experience it for themselves. And so if farms are interested in utilizing it, all they need to do is be able to call the conservation district up to schedule some days on the calendar. We have a rental agreement that needs to be completed and signed, and we need a certificate of liability insurance submitted with the rental agreement. And then since there's no payment for the first 2 years, then that's all we need. And so once we have that, we would then work with Bruce as the host partnering farm to introduce the grower who wants to utilize it to the piece of equipment. And so Bruce has created an excellent guidance document based on some of the materials that Sue had originally given us, and he's tweaked them so it's for our model specifically. And so that's available on the website now, and we'll be adding to that and improving it as we learn more as well. And then, you know, Bruce, I think, will be available as a consultant to be able to give tips to growers on how it works. Be happy to take any follow-up questions about that too, if I didn't cover sort of what you're looking for about the rental program.
There was one other question, Amanda, about storage of the unit. So if someone were to rent it, does that need to be stored undercover, or is it okay to leave that out in the field?
It's a good question. So it is undercover during the winter months when it's not in use. We think that was really important, and that's something that Piccadilly Farm and Bruce has taken on as the partnering farm with this. We don't anticipate that it would need to be undercover for a couple-day rental. We understand that that might not be a possibility for all growers to be able to have a place to keep it undercover.
The unit that you guys have has got a side eject exhaust as opposed to the old style upright one. And the upright one has the problem that when it rains, the water goes into the chamber, which is not such a good thing. So you shouldn't have a problem unless it's raining sideways for it to be outside.
There was another question. Joanne, do you want to unmute and ask your question about the timing? I'm not quite sure I understand.
You know what? I don't know if I'm on, if I've got a, can you hear me?
Yeah, we hear you.
Okay, I didn't know if I had a microphone on. So the 2 years, I didn't know if it meant as in 2021 and 2022, or 2 years of the first date that you borrow the steamer.
Thanks for the clarifying question. I meant 2021 and 2022 for those growing seasons. We see them as a learning opportunity to partner with the farms in the region.
Thank you.
All right, so, oh, this was from Becky, sorry, I didn't see that. So she mentioned that she was warned about scaling in her steamer, that they have hard water, right? Something to keep an eye on for us.
Yeah, so there's a yearly service that you can do. It's a boil out service, and usually any heating company can do it, but you can do it too. We actually invested in, it's like a small circulation pump and a mild acid, and you hook it up to the and you just make a loop, and it goes through, and it's a descaler, and that's what it is. And it doesn't really need to be done every year, I don't think, but it's definitely, you know, couldn't hurt, and it doesn't take forever to do.
I can add in a couple of quick things related to our specifics. The unit that we have does have a descaling goop that the water has to pass through. It looks a lot like a water filter on the outside, but it's got the scale inhibiting goop in it, and so that will also help. And we'll be able to get to that with annual maintenance as well. From the point of view of people just renting the unit, you'll drain out all your extra water at the end of both the tank itself and then also the little water feeder valve, and that'll help reduce the opportunity for particles to form and adhere and stay inside the tank and all. Also related to the rental, this trailer hitch is set up for a 2 5/16 inch trailer ball. So you'd want to have that ability to tow. And the idea also with the rental agreement is that you get the unit with a full tank of diesel in it, and then you return it with a full tank. So there would be some cost to you just to replace the fuel that you've used.
All right, and thanks, Bruce. So we did have another question come in. This one, Andre, is directed towards you. Mentions that you said with 14 tunnels, you don't have time to steam each tunnel per year. What's the scale for a unit like the S20 acreage per model? You know, how much?
I have no idea. It's about, as Becky pointed out, the real issue is timing. So I'm greedy, and so I have tomatoes I have a crop in the tunnel, right? And then that crop is a summer, fallish crop, and I want that crop out, and I want the greens in there in time to make me money during the winter. And so then to maximize that shuffle is a small window. And with that unit, it takes me 12 hours of runtime to do one 30 by 96 tunnel. And that's with me being like on my game. So that's essentially, I do a tunnel a day. Sometimes I'm lazy and I don't. I have to do like one more bed the next day or something. But if I'm really on it, I can do a tunnel in a day. I get up and, you know, I have my little headlamp and I'll move some chain and stuff like after dinner, and, you know, just to get it done that way. So then if I was going to do that and work every day, then I could do all those tunnels in 2 weeks, which might be enough time to do a transfer. But that's asking a lot and asking for me not to do pretty much anything else. So that's what I'm talking about. If you're doing acreage, it implies that you want to do the stuff outside. And I would recommend a walking steamer for that, not one of these static units. So you're talking about a lot more money, but you're talking about being able to go and do like outdoor steaming, like the old tobacco farms had the walking steamers that like would go along. And like what they're doing out in California to replace methyl bromide.
I just want to check with Amanda and Andy to make sure we're okay on time for another question or two. Okay.
Yeah, Jeremy, I'd say maybe 1 or 2 questions, but then we're gonna, Zoom's gonna automatically shut us off here.
Okay.
Pretty soon.
All right. Well, just to follow up on that, Andre, with and Bruce, with the unit that we have there with the dual output nozzles there, is that something that we should really be looking at to I mean, does it have the capacity then to do 2 of those beds at once? You know, are we able to do that? And, you know, if so, would there be any reason to only do 1 at a time to kind of just help speed up that process?
Andre?
I designed the machine for the county with that dual thing. And my thought at the time was setting, it takes 20 minutes minimum. Bruce might be able to attest to this because of the same size beds that I have, but Becky has different size beds, so her timing is different. But minimum 20 minutes to do a transfer. Like I can't see you doing it any faster, but it probably would take longer than 20 minutes. So then if it's 12 hours of runtime and you have 6 beds and you're another half hour, that's another 3 hours to do a tunnel, and you're just transferring stuff. And so what we started to do is set everything up. And like Bruce is saying, you can't touch it. Even if you could touch it, you can move it in 30 minutes, but it's so hot that you can't touch it. So we ended up with a wider tarp to do 2 beds at a time. So we can use one of the chains down the middle as the common chain, right? But then we can flip it over and we could put a sock We could do all of our stuff, flip it over, put other chain around and everything, and just have the manifold, and we unclick the steam from the one manifold and hook it up to the other manifold, and then just go. And then while the other one's cooling, we can then start to move everything from that bed over to the other bed. And so then you're using your run time as setup time. So thus reducing the overall amount of time it takes to steam a tunnel by 3 hours was my idea. What do you think of that idea, Bruce?
Well, I'm still new enough to it that I'm trying to figure out the best strategy, and that does seem like a great idea. And but I'm also not sure if you could get two socks going and do 2 beds at once. It would take longer to do, but would you get uniform enough penetration that you'd only have to be moving a bigger tarp less often? Or if you use 2 socks in a 5-foot area, does it reduce your steam time such that you gain time and then you just keep moving one tarp down with both socks in it? I'm not quite sure what's best. I think I need a little more run time, and that may be something that we can develop as a group knowledge base too, that's going to tell us what's the best strategy.
And Bruce was also dealing with a really inexperienced and inefficient crew the last time that we ran that at his place, all of us included. So he did good just to keep us moving in the right direction. So with that, I want to thank all of you for all the information that you shared today and all of your knowledge. I think you shared some great insight, and this is a learning community, and so we're all glad to be a part of it together, and hopefully we'll all be able to contribute and come back together again in the future to share more of what we've learned and more of our experiences, and learn more from some of the research that Becky and others are doing. So with that, I'm going to turn this back over to, I believe, Andy, you're up next. I'm going to hand things back over to you. Thanks again, all.
All right, thanks, Jeremy. And I think just hearing your message about opportunities to share information, I've noticed in the chat that Sean Broderick is on this video conference, who's been doing research with steaming in high tunnels in Mississippi. And I think, Sean, you may be hearing from perhaps Jeremy and I, and maybe we'll grab Becky, but to maybe pick your brain and hear about some of your research and what we can utilize for here up in the Northeast. On that note, I do want to thank Bruce and Andre and Becky for sharing all the great information today with us, as well as all of the project partners. As a reminder, this session was recorded, and we will make it available in the next few days on the Cheshire County Conservation District website, along with the UNH Extension website and the ATRA program website. And also just want to make folks aware that we will also be doing a on-farm demonstration of the steaming unit at Piccadilly Farm this fall, which is located in Winchester, New Hampshire. So please keep checking with the Conservation District as to when that date will occur. And also for any questions we didn't get to in the chat, we'll make sure to record those and follow up as best we can. And on that note, I just want to thank everyone for your time today and joining us, and look forward to, as Jeremy said, learning from everyone in terms of what we learn on our farms with soil steaming. Thank you so much.